In lesson C7, you're going to be exploring scientific notation. We need you to develop an understanding of the system of scientific notation and represent large and small numbers using them. So, first I just want you to think of multiply means by 10. So, pause the video for right now and multiply each of these by 10, 100, and 1,000, get your answer, and divide by 10, 100, and 1,000. And what I want you to think about is there a shortcut? So if we were looking at those, you should have had 92, you should have had 920, you should have had 9,200. Simple rule, when we multiply for a shortcut, when we multiply by a power of 10, what are we actually doing? We're looking at the power, and it's 10, it's 100, it's 1,000, and we are counting the number of zeros. And as you count those number of zeros, you are simply then going to move your decimal that many places to the right. So count the zeros, move the decimal that number of places to the right. So if you think about that, here we moved it over one place, here we moved it over two places, and here we are moving it 3 places. Now, if you didn't do the division by 10, division by 10 is very similar to that. When we divide by 10, here we should have had 8730, or 873. Here we're going to have 87.3, and here we would have 8.73. So again, we count the number of zeros and we move back 3 places. We count the number of zeros as 2, we move back 2 places, 1 0, back 1 place. So when we divide by a multiple of 10, what we are simply doing is we again count the zeros, and once you count those zeros, this time you're going to move the decimal to the left that number of places. This helps us with scientific notation. Some of these, we already talked about a quick way of figuring these out. Remember, 10 to the 4th, a 1 followed by 4 zeros. 10 to the 3rd, 10 to the 2nd. So 4 zeros. So we have 10,000, 1,100, 10. And anything to the 0 we should remember is 1. If we were looking at these in the value, we might put 0.1, but as a fraction it would be 1/10. Remember, rewriting it would be 1 over 10 to the 2nd, so 100. 0.01 is a decimal. This one would be 0.001. 1 over 1,000 would be our decimal. This one would be 1 over 10,000. Remember the reciprocal of 10 to the 4th. Thousands place, tenths, hundredths, thousandths, 10,000ths, and we put a 1 in our place. So, ways of writing numbers. We want to define what is standard form. So when we think about standard form is that regular way of writing a number. When I think about the regular way, I am talking about what you see on your calculator, what you see in the paper. So my example is going to be 2,500. The regular way of writing a number. No decimals, just that whole number. What is product form? Sometimes we refer to this, you'll see, as the expanded form. That's when I would write this as 2.5 times, and we're going to write this out as 2.5 times 1,000. So again, we're always looking at this number, standard form. This would be my expanded form. What does it mean for expanded or product form? It means the first number is written as a decimal, and we always want to think of it as between 1 and 10. So 2,500, I place it between the 2 and the 5 to get 2.5. So that first number is a number between 1 and 10. And then it's times 10, or in this case, a multiple of 10. So times, we want to think of that as a multiple of 10. And the multiple of 10 that I have to take 2.5 times to get 2,500 is 1,000. Well, we're going to mostly be writing from standard form to scientific notation. Scientific notation, again, the first number is always going to be written as a decimal. So it kind of starts the same as the product form, written as a decimal. Again, between 1 and 10. And then instead of times a multiple of 10, instead of times a multiple of 10, we're going to take it times 10 to a power. So in this case, if I was writing this one, I would write it as 2.5 times, what is 1,000? 10 to the first, second, third power. This would be my answer in scientific notation. So, using these definitions, I'd like you to try and do the next two tables. We're going to kind of do them together, but I'll ask that you pause the video at different times to try and fill yours in. Standard form, remember, is kind of like that decimal that we'd see. These are all going to be larger numbers. Product form, writing it out as times a multiple of 10, and scientific notation. So again, if you're filling in your table, you might fill this one in as 2.4 times 10 to the 100 is going to be to the second power. 8,500, again remember, first we have to have a decimal, so 8.5, this one is going to be 3.4, and now we're taking it times, well, to move this one over, I would actually have to take it times 1,000. What am I taking 3.4 times to get 3,400,000? I'm taking it times 1 million. So now these ones are going to go backwards, and here we're going to write it in scientific. So again, keep the 8.5, 10 to the third. 3.4, 10 to the 6th. 5.1 times 10 to the 4th. 7.25 times 10 to the third power. If this is 1.5 times 10 to the third, this is still going to be the 1.5, still 3.6. But now instead of 10 to the third, we're going to write 1 followed by 3 zeros. Instead of 10 to the second, we're going to write 100. If I'm taking 5.1 times 10,000, I'm going to get 51,000. 7.2 times 5 times 1,000 is going to give me 72,500. When I look at 1.5 times 1,000, I'm going to have 1,500, and here 360. I was hoping you can fill that in, but if you needed to look at it as we went through. Please try filling in this next one, similar to how we just did that. Again, noticing 7.8, 5.2, oh, this is kind of nice in the bottom, if it was 2.6, and 4.9. Pause the video, and then you will see me helping you fill this in if you need to. All right, so as we are writing this, we should have 5 times. When we look at the number of 1, 2, 3, if we are looking at the number of zeros behind it, it goes back 4 places, so 10 to the -4. Remember, this one went back 3 places to where the 1 was, so we had a -3. Here we're going to have 7.8. We need to have our decimal between these two, so we should have 7.8 times 0 point, and we should have 4 zeros and then a 1, which gives us 7.8 times 10, and in this case, 4 zeros and 1 means 5 places back, -5. Here we're going to have it times just 0.1, which is 5.2 times 10 to the -1. You should be able to do the scientific notation part of both of these. Take a look at the place value, counting 1, 2, 3, 4 back, 10 to the -4. 1, 2, 3 back, 10 to the -3. That should help us now when we do these last two. If we are looking at them, this was to the -4. That means I need to go 4 places back, 3 zeros and a 1. 2 places back, 0.01. This is my second place. So now I'm going to write them in standard form. Standard form is our decimal form, 00029 for this one. In this one, if we think of moving our decimal point or writing that one, we're going to have 0.00387. Again, this one, we need to think of our decimal place being 4 places back at 0 point. We're going to have 3 zeros, 26. 4.9 times 10 to the 1, 0.049. And what we really want you to look at is how did we get from this first column to the last column in both the first one here and to here, or vice versa from scientific notation. How could we look at that? Think about where our answer is in scientific notation, where that decimal is. Always the first number between 1 and 10. So if we describe any patterns that we can see, and I want you to take a look at those 2 tables, and we're really looking at problem 4 right now. So looking at that first table that we made. If we are changing from scientific notation, okay, to standard form, that means if I want to go from the last column to the first column, standard form. This one, all of them, notice, have positive exponents. So if I have a positive exponent, every single one of these had a positive exponent. When I look at that, when I think about my final answer was always a number that was greater than 1. All of those were pretty big numbers. What do? We are moving the decimal point to the right. So we move that decimal if we are doing it, we're going to move it to the right. And if you think of an example, if we have 7.2 times 10 to the third, that's going to be a big number. We're moving the decimal 1, 2, 3 places to the right. 7,200 would be our answer in standard form. When we look at the table 5, that's where our scientific notation. And as we look at that, we're changing from scientific notation again to standard form. And when you go from scientific notation to standard form, and you have a negative exponent this time. So whenever we're working with a negative exponent, our answer, our final answer, is going to be a number that is a decimal. So we're going to always have that decimal number for an answer. When I talk about that negative answer as a decimal, if we think of this problem, 7.2 times 10 to the negative 2. That's telling us to move the decimal to the left. So here we moved it to the right. Now, when it's a negative exponent, we're going to move the decimal always to the left. So that our answer would have been, we move it over 2 places, 0.072 for our solution. In your homework tonight, the first thing is just asking you to put greater than 1 or less than 1 that we're going to do tomorrow in class. The next part is asking us to write in scientific notation. What we will probably do in class is try and get a few more examples to look through before we begin working on this worksheet. And then we'll have another worksheet that I'll be handing out. So hopefully by the time we take a look at those, they will make a little more sense. But go back and watch that video again. We're going to be asked to go from standard form to scientific, and from scientific notation to standard form. So we'll probably practice a few more. Look at tables 4 and 5. That might help you out.